Right, for this lesson we're going to talk about what is meant by quadratic equations, and then finally we're going to talk about how we solve quadratic equations by factoring. And first of all, let's talk about what are quadratic equations. Now really before we get to that though, we've already had types of equations. For example, we've had equations where you have 2a plus 7 equals 3, and then we've solved them. You know, we've had other variations where maybe you had a negative 2 parentheses x plus 4 equals 7, and we've used the distributive property to solve them. And we've been working with these type of equations. Now, quadratic equations are a little different. The first question is what is a quadratic equation? Well, a quadratic equation really, it sounds a little complicated or something that you may have not have heard of, but really it's not too hard to understand what a quadratic equation is. All a quadratic equation is simply it's an equation where the largest term has an exponent of 2 or a degree of 2. So to clear that up, say I had 2x squared plus x plus 3 equals 7. Okay, now this is an equation. Remember, an equation has an equal sign. Now I have 1, 2, 3 terms, and eventually, you know, I'd still have 3 terms if I brought the 7 over and so on. But more or less, I've got something that has 3 terms. Now, when we say an exponent of 2, a quadratic equation, the largest exponent is 2. That's all you got to remember. So for example, in this term, well, you can see you have an exponent of 2, right? In this term, it's an exponent of 1. And here, you know, really I could write as 3 to the first power. The largest exponent in this whole equation is 2, and that's what simply a quadratic equation is. Now, to continue with this, there's a certain rule or a theorem that we're going to talk about. And this is called the zero factor theorem. I'm going to write that out. And really all a theorem is it's something that's always true. And what the zero factor theorem says is if I take some number p times some number q, and if that is equal to 0, if I multiply two numbers together and the product is 0, well, how would I get 0? Well, either p has to be 0, or q has to be 0, or both of them have to be 0. That's the only way that I can multiply two values together and get 0. One of these has to be 0. I mean, if one of these aren't 0, if they're both some number other than 0, there's no way I'm going to get 0 as a product or an answer. And this is called the zero factor theorem. So when you multiply two values together, one of those values has to be 0. One or both of them. Okay? So let's kind of keep that in mind as we go along here. Now in example 1, I believe I have 4 examples, and these go fairly fast. They look like they have different directions, but really they're asking the same thing. Now in example 1, it says find the roots, and remember what a root is. It's a solution, it's an answer. Find the answer or answers of this quadratic equation of x squared minus 18 equals 3x. So again, I kind of emphasize that we have a quadratic equation here because the largest exponent is 0. Or excuse me, the largest exponent is 2. Now how do we solve this? Well, we get everything on one side. Now the majority of the things are on the left side of the equal sign. So what we're going to do here is we're going to cancel this out. What could I add or subtract to cancel it? Well, I could subtract 3x from both sides. So that's what I'm going to do. So these cancel, right? So what do I have left on the left side? Well, I have that x squared. Now I'm going to write this in descending order. So I want that minus 3x next, and then that minus 18. And finally, on the right side, what is 3x minus 3x? Well, 0. Now, okay, I've got that quadratic equation on the left side, and the only way I can solve this here for now is what we call by factoring it. We're going to factor this quadratic equation, and we've talked about factoring, haven't we? So we're going to take this and we're going to see if we can factor it. And we're going to keep the equal to 0 in there, because we need to, because that's what we have in this problem. Now the second sign is minus, which means I have a plus and a minus. And since the signs are different, I want two factors of 18 where the difference is 3. So let's see, two factors of 18, 6 and 3, where the difference is 3. The 6 has to go with that first sign. So our largest factor has to go with that first sign. So the 6 goes there and the 3 goes there. Okay? So what we just did is we factored the quadratic equation, and that's equal to 0. Now let's keep in mind that zero factor theorem that I mentioned just a little bit ago. Really what we have is one value times one value being equal to 0. Well, what's the zero factor theorem say? Well, one of these, either this value, whatever it is, or this value has to be 0. So either x plus 3 has to be equal to 0, or x minus 6 has to be equal to 0. Now let's solve each of these. So let's see, they're adding 3, so subtract 3, and I get x equals a negative 3. Or, in the one on the right, they're subtracting 6, so I'll add 6, and what I get is x is equal to, let's see, 0 plus 6 is 6. So really, I have the potential of having two solutions here. Now, I'm not going to take the time to check this right now, but if you put a negative 3 in for x up here, it will check. Okay, that will work out. So in other words, if you took a negative 3 and you squared it and you subtracted 18, you'll get the same answer as taking 3 times a negative 3. So it would check. And the same thing right here. If you put 6 in for x, it would check out. And the next problem we'll go through and check it. All right, in example 2, we're going to do the same thing. Find the roots of a negative 25 equals negative 4x squared. Now, what I'm going to do is I'm going to factor, or first of all, I'm going to get everything on one side. It really doesn't matter what you do here. You want to try to get everything probably on this one to the left side, okay? So in other words, if we're going to have a chance to factor this thing, we want to make sure that we have a situation where I'm going to factor a trinomial. What's the only other way to factor? Notice here I just have two terms. What's the only way to factor something that's a binomial? And if you recall, the only way to do that is if it's the difference of two perfect squares. So I'm going to bring this over to the left. So let's see. What could I do to negative 4x squared? Well, add 4x squared. So I'm going to add 4x squared over here. All right, so what I have then is I have 4x squared minus the 25 equals 0, because these cancel out, or in other words 0. Now what I have here is the difference of two perfect squares. And remember, the difference of two perfect squares always, and remember this is equal to 0, it always factors into a plus and a minus. Alright, what are the perfect squares of 4x squared? Well, 2x and 2x, right? This is first, so it goes in the first part there. And then what are the perfect squares of 25? Well, 5 and 5. Now I'm going to use my zero factor theorem and solve this now. Now either this is equal to 0 or this is equal to 0, or possibly both, which we're showing right now. So the 2x plus 5 has to be equal to 0, or the 2x minus 5 has to be equal to 0. Now let's continue and solve this. So they're adding 5, subtract 5. So 2x is equal to a negative 5. Divide by 2, and I'll leave it as a negative 5 halves. Because 5 over 2, they don't divide evenly, and it's in lowest terms. You don't have to write it as a mixed number. Over on the right side, I'm going to add 5, because they're subtracting 5. So 2x is equal to 5, and then divide by 2, and in this situation I get a positive 5 halves. Alright? Now if I check this, and again this will check, if I put, for example, this value, if I put that in for x right here, squared it, took it times 4, and subtracted 25, I'll get 0. Or if I put one of those values in here, it would check out. Okay, example 3, really the same directions. Instead of them saying find the roots, it says find the values of x that satisfy this quadratic equation. Now, I could bring everything over to the right, or I could bring everything over to the left. The problem is, if you're going to have a chance of factoring, you really want that that quadratic, that term that has an exponent of 2 to be a positive exponent in front, or a positive number in front, I should say. So we definitely want to bring everything over to the left. So what I'm going to do, let's see, what could I add or subtract to a negative x squared? Well, add x squared. So I'm going to add x squared over here. Now I'm going to write this in descending order. So I've got x squared first, and then my positive x, because it's not negative, it doesn't have a negative sign in front of it, minus 56. And then what's a negative x squared plus x squared? Well, that's 0. Now, I got a trinomial. Let's try to factor it. Alright, so the second sign is minus, which means I have a plus and a minus, and it goes x and x. So since I have two different signs, I want two factors of 56 where the difference is 1. And that would be 8 and 7. The larger factor, 8, has to go with the first sign. So 8 has to go there, 7 goes there. Now let's finish this out now. Either this equals 0 or this equals 0. So either x plus 8 is equal to 0, or x minus 7 is equal to 0. Now if I solve the one on the left, I get x equals a negative 8 because I'd have to subtract 8. Over here I'd get x equals 7 because I add 7 to both sides. Now, you do want to get in the habit of checking these, and I know I haven't checked these as we've gone along just for time's sake, but let's check one or both of these values. Alright, so what I'm going to do here is I'm going to go back to this original equation up here and see if this checks out. So let's put in, say, 7. Let's use a 7. Alright, so 7 minus 56 should be equal to whatever the opposite of 7 squared is. So in other words, you're going to take the opposite of whatever x squared is. Alright, so 7 minus 56, let's see, that's a negative 49. Is that equal? Let's see, what's 7 squared? 49. What's the opposite of 49 and negative 49? Notice it checks out. Now, if I did the same thing with the x equals 8, let's see if x equals 8, if that checks out. And we'll go through this check here fairly fast here. So I've got, I'm going to put a negative 8 in right there. So I have a negative 8 minus 56. We're going to see if that's equal to a negative 8 squared, the opposite of a negative 8 squared. Remember, whatever x is, you're squaring. So let's see, over on the left side I have a negative 64. What do I have on the right side? Let's see, a negative 8 squared is 64. What's the opposite of 64, negative 64? Notice that both of these check out. I do have two solutions. Now the thing you want to keep in mind is that sometimes both solutions won't work. Sometimes neither will work. You'll get into some of those situations. Now here in all our three examples, this one we see that both solutions worked. And in example 1 and 2, I told you that they would work. We didn't take the time to check them. So you want to make sure you check your solutions to make sure that they do work. So what we've talked about is what is a quadratic equation and how we solve quadratic equations by factoring.